How's it going, everyone? Back for another session of building out this MSP430 disassembler. Looks like the audio's good, video's good. Actually, let me get some lights turned on before we start. So, yesterday we finished up the single operand instruction decoding and parsing, as well as a bunch of refactoring that cleaned up the general structure and API of the disassembler. We have most of the implementation done at this point in terms of decoding and disassembly, and what is likely to be pretty close to what the final API is going to look like. We're still not doing printing of the disassembly. That will come probably not today, but probably the next session or two. But today we are going to wrap up, or at least work on, the two operand arithmetic instructions. So those are all of these right here. We haven't implemented these yet. Yesterday after the stream, I did a little more cleanup and just refactored a little bit more to simplify the package layout a little bit. We added instructions separate package, and that just didn't really seem necessary given like the amount of code that we had and everything. So I just brought it out. It solves our re-export problem a little bit, where yesterday we were doing like a bunch of pub uses and everything. So that's no longer a problem. But so there's probably going to be some more refactoring we have to do today. One of those things being this code right here is probably going to have to come out into its own function, because the addressing mode for the source is used both here in the single operand arithmetic instructions, but also down here. I don't really want to retype all this or copy and paste it, so we're probably going to turn this into some kind of function that we can pass in data to and get our addressing mode out of. But I'm not going to start there. I think to start with, we're going to start on getting the match statement together to do the parsing of the opcode out into its individual pieces. That seems like the most straightforward place to start. We'll see how long we go today. I don't really want to get too far past any of this, if we can even finish this in time. And the test writing is really getting to me, but I want to make sure this is well tested. You know, we saw how important that was in the refactoring stage, and I really want to make sure that this is like a well tested library. So let's go ahead and get going. We have to do a few things. One of them is we have to get the actual opcode. And so to do that, we're going to do a little bit of bit magic here. First word, we're going to shift that by 2 operand. What did I call this up above? A single operand opcode mask. So we're gonna mask this off. Then we're gonna shift it by these are 16 bits wide, 4, 8, 12. So that's gonna be our opcode. Our source is going to be sources are also 4 bits, I believe. Yeah, because they're the same as over here. And we're going to shift this by 8. AD, first word. So AD should be 1 bit, I believe. Yep, it's 1 bit, and that's at 7. At 6, 5, 4. Yep, okay. That's the width. We call that operand width. Okay. So the operand width. Source, addressing, operand AS4, and then destination equals first word to operand destination. And we don't have to shift this because it is already at the end. Let's define all these up here. And these probably all get cleaned up as well. Right now they're kind of a mess, but so the operand opcode mask, that's going to be 1111. It's 1, 2, 3, 4. All right, the AD, so that's 1 bit. So that's 4, 5, 6, 7, 4, do that. So the operand width, So those are all of our constants for our masks. Let's set a breakpoint here. Let's make a new test, and let's verify that that we are actually masking all these things off, right? What's the first one? We'll do a move. So if we're gonna do a move, let's our opcode is going to be 0, 1, 0, 0. Our source, we'll do 15. The destination, do register direct. Register direct will do 16 bits. The source will do register direct for that as well, so 0, 0. And then destination can be 15. So it's moving R15 to R15. Effectively, like what this instruction is this. So looking at this, it's going to be 4 F 0 F. We're doing this backwards because it is in Little Endian. But yeah, let's debug this. So, destination is 15, our source is 15, our opcode is 4, which is correct. This is opcode 4. Addressing source is 0, which is correct. AD is also 0. All right, this looks good. All right. So it looks like we have two destinations. One is index, which means that there's a second argument, and the other is register direct, which means that there is not a second argument. We're going to match on AD, and if it is 0, 1, underbar, so this is unreachable. Destination. All right. Register direct. So we might want to change this to source addressing mode. I don't know if it matters enough, but pub email and so this will be a register direct, which is a U8, or a indexed, which is a tuple of U8 and an I16, which is the value. So we're going to do addressing mode, destination addressing mode, register direct, and this will be destination. So if this is the case, then we have to do a little bit of work. We have to read the next byte, the next word. And so here's the thing I don't know for sure is the ordering of everything. So like, I guess one of the easiest ways to do this is to assemble it and then see what it assembles as. Let me switch over to webcam really quick so I can type my password in. And let's go to the assembler. So basically what we want to know is which order everything comes in. So we can do a move, call it move 10 into 2 of R15. And this would be like, I think the biggest instruction you can have, which is like 3 words. So here's 1. Here's 1. Here's 2. Here's 3. So it looks like the source comes first. Source has a so the logic here is going to be a little bit different. We have to figure out like, I wonder if it makes sense to can we do this? to, does that work? I guess that does work. So maybe this is what we do is we scope it down. Is this the remainder? Because we have refactor after this. So equals if remaining data len is less than 2, panic no source, no destination. And then we're going to go from 0 to 2. So this is the code for doing destination. So we're gonna match on the opcode and add C, sub C, CMP opcode, DADD, bit, bic, this, XOR, and then we just have to do this. Unreachable. Never use. Okay, let's go add all these constants. So this is going to be 4. This is 5. That's 6. 7. I wonder if this starts from... Hey, Caffeine Writer. Yeah, I gotta do the same. Like, a few days ago when we were starting this, it's been like, literally months since I've written any Rust, and it was pretty rough getting back into it. You working on anything right now, or any kind of projects that use it? Sub is 8. This is 9. That's 10. These all just go up. It's 11, 12, 13, 14, 15. Yeah, okay. And so we're going to have to do... Oh, what do we have here? This is a U16, I think. So we'll just make all these U16s. Cool. Launching it for a company or anything, like, or just for fun? Yeah, we built a project at my company called A-Shirts, and I was looking to originally build this in Rust, but the UI libraries just like weren't mature enough when we started doing it. The Qt bindings for Rust like weren't really there yet. I still don't think they are, but I think they're significantly better than they were. So we ended up writing this all in C++, which was not as pleasant as it could have been, but it seems like things are moving. I haven't really seen anything really like production ready come out that's like ready from the Rust side. Have you? And we're gonna need. Man, I wish the keys like were the same as the Mac one because I know all the hotkeys on the Mac, but they're all different on Windows. Yep. And then we need to go into instruction and we have to make our so remove, add C. It's already a trait, probably. Sub C, sub paired bits dic bis XOR and so let's go ahead and make all of these. Source. It's gonna have a source, it's gonna have a destination. Yeah, so I've seen the image UI bindings, but I haven't heard of any of those other ones yet. Let's look this up really quick. So are these? Is this web-based? It looks like it has JavaScript support. Maybe it uses Qt under the hood. Okay, so you have different runtimes. You can use the GL runtime or you can use the Qt one. This is interesting. Oh, so it's somewhat declarative? Or is declarative? Yeah, so this is it looks like this is declarative, which like Qt has a way to do declarative UI, but I haven't really seen, like we used it when we first started, and we ran into problems where it just wasn't robust enough to actually do what we wanted to do, and we've since like ripped out all the declarative stuff and moved over to code, and haven't really looked back from there for it. And what was the other one? There was FLTK. I'm assuming that's just a Tkinter one. I don't know what FLTK is, but full tick. The Fast Light Toolkit. Cross-platform C++ GUI toolkit for Unix, Linux, Windows, and Mac OS. .3D graphics with OpenGL and its glut emulation. Interesting. Yeah, I've never even heard of this. I've never used TK. I've written a little bit of Tickle, unfortunately, but yeah, I've never heard of this before. Was there a third one? There was the web view. Oh yeah, so it is just all web. This is cool. I mean, like it means it's easy to build. Yeah, I mean, like all of the scripting languages all have like Tkinter bindings. Like that was like a big thing that Ruby had when it was big, and there was some like really gross like UI stuff that I'm sure Python does as well. All right. So let me go back to here real quick and see. So I think we're basically going to have an addressing mode and operand with a source addressing mode, a destination addressing mode, and a an operand with. Oops. Nope. Destination. And then operand with. I think this is just a. U8. And the streaming apps written in scripting languages, Beast 2. Yeah, so I haven't really played with Electron, but I did play a little bit with doing. So in Node, you can, if you build it, you can specify the file that it loads by default, and that allows you to kind of package things up into its like a thing where like you could distribute like a Node runtime plus like the application all in one bundle. And I did play with that like a long time ago, back in maybe like 2012 maybe, 2013, 2012, maybe before that even. But yeah, no Electron yet. I've been trying to avoid it. and avoid as many Electron apps as possible. I mean, the memory and size is a lot for Electron, but I'm more concerned about like the security implications of it. I mean, like it's like all the time. There's always new like code exec bugs that come out, and like some of the big players, I think like Slack like has put a lot of work into it, and I'm not sure like who else, but like constantly people are just like using it wrong or insecurely, and they put all like because like XSS turns into like code exec in a lot of cases just because of like what you can do once you have that. Kiba clone. Pub new. Oh. Operand width. So one of the things about these two operand instructions, thank you, Mr. Edmakes. One of the things about these two operand instructions is that we're always going to have the BW field here, whereas in the single ones, it was only present in some and it defaulted to being 16-bit. So all of these should have them. Destination addressing mode. S mode. So we want source, mode. Wait, I don't need that. What is it? Function, oh. Destination address. That's a destination address in mode. I have no idea if that is spelled right or not, but I'm gonna take your word for it. So we basically need to go and generate a whole bunch of these now. One for each of these instructions. Move. This is probably a good place to use a macro, but I don't particularly want to write one right now. C, sub C. Sub C with sub. Compare. CMP DADD. Bit with BIC. This. This. XOR. So yeah, maybe we'll refactor this a little later with a macro, and we don't have to. We can get rid of a whole bunch of this code and make it significantly easier. But we should see that these resolve now. I'm curious. So that is the interesting thing here, is that there is some overlap here in terms of opcodes. I wonder why they decided to start the opcodes here at 4. So basically at the end here, it might be reserved for future use. It's just weird that you would reserve the lower ones rather than the higher ones. It might have just been like some optimization they did where the silicon at the time was set up to make that easier to parse. But I don't know. Or maybe these were added. Basically, these 3 were added maybe after the initial implementation of. I guess it wouldn't make sense though. I don't know. It's not really important though. All right. So. Yeah, I don't know. It is anyone's guess. Maybe we'll find someone that knows MSP430 well enough they can actually tell us. So, the next thing that we're going to have to do is we're going to have to turn this code right here into a function so that we can pull it out of here and reuse it. Pub function yes mode. We're going to turn addressing mode. And we need to pass in a register, I think. That's not what I wanted to do. So I think what we're going to end up returning is a tuple. And it'll be an addressing mode and a remainder. U8. And we need a register. We need a source. Right. What is register here? Register is a U8. Source is a U16. And where does one's complement live? Addressing mode does not have a known size. Can you not return an enum? I wanted to return just an addressing mode. So that works. Let's do this first. So we're doing some here. Does it ever return none? It does return none, just right here. I wonder if it makes sense to add an exception for just this, and not worry about it. And then it can always return. Oh, come on. What are all these? Oh, okay. So none of this should be possible. Like, this should all fail to build because data doesn't exist. I don't know why it's not complaining yet. We can comment this out for right now. Like this should all fail. Trying to isn't going to exist because we don't have this there. All right. And we do need to have this still in here. And we got to pass in remaining data. Oh, typos. Subcressing mode. Oh. Let's see if this fixes if there's more things. That all happened from that all happened from our changes. Subressing mode. It's for all of them. Addressing. How many more left are there? digressing. Distressing. And dressing. All right. Split at, I think this does return a remainder. All right, we're getting close. Destination addressing mode. Oh, okay, I was gonna add them here. So a whole bunch of tests just failed, which is good. It means that we're catching stuff. Why did they fail? But a whole bunch of tests passed. Basically, it looks like everything that has a second parameter failed. Which means that maybe the remaining data is bad. So, divides one slice into two at an index. The first will contain all indices from 0 to mid, excluding the index mid itself. The second will contain all indices from mid to len, excluding split at 0, split at 2, all right, so remaining data. First of all, is this going to move it, or is this going to pass a... Yeah, so it does need to be a reference. So the register is 0, which is correct. Source and data. That's weird. No. Why does it not have len? Yeah, it's there. No member named len. That's interesting. Why does it not? So this won't print in the test, but it might be enough to get it to actually, yeah. So it thinks the length is 0. Why do you think the length is 0? Adder plus 2. Call PC immediate. Why? Am I using it wrong? Oh. That'll fix it. All right. There we go. And now we're also set up to return the remainder if we want to. Which is great. All right. Add checks. All right. So that's getting us pretty close. We're going to have to make a decoder for this, but this is really simple. I mean, I guess we don't have to. We already wrote it. It's right here. So we can see if we can return a tuple here now. And then let's do this one. Main data. All right. And let's just fix all these. We don't need this because we're not going to use it again. All right. Perfect. Mode remain parse AS mode reg source. It's source addressing. The register, the addressing mode. Is that what it is? It's the mode? Yeah. The source and then the mode. Expected, so this should actually be a U8. Can we not? Oh, it needs to be instruction. Do we not have move here? Is it scoped? Expected a U8 and found a U16. So we can go in and we can make the remainder of these real quick. And let's write like a test. I think once we write like one test, I can wrap it up for the night. Just to verify that things are working properly. And then like the next session we can go in, or maybe I'll just do it on my own time so I don't bore everyone with writing a whole bunch more of like the same type of tests. But effectively, like once, assuming this all works and this test works, then I get the rest of the tests in, we're basically ready to start on printing. I mean, this was like the big like last step. All right. So we should read on these tests, and all the tests should still pass. Found addressing mode. I think we have an unexpected value found module addressing mode. Oh, because it should be source addressing. So there's a whole bunch of unwraps here. This is really unsafe. I guess it's not unsafe, but it's not very good error handling. We'll do some refactoring to clean this up. So running this again, these should all still pass. Match arms have incomplete type. Incompatible types. Why are they incompatible? Oh. Destination. Oh. It's AS mode. Cool. Yeah, it's getting there. Like the code it's getting there. There's still a lot that's like really not great here, but we'll add some more safety to it and get things a little more reasonable. So this is working because it is just doing register to register. We should be able to do one that is 3 words long. So we can make sure this works. So let's see here. Move source is going to be R15. Destination is going to be 1. W is 0. AS. We'll do 1. Be 0, 1. 15. So this ends up being maybe like 2 to 2. So this ends up being 4F. Let's 9F 0200 0200. So I think this will give us this. And it's gonna move. So our AS source addressing mode. Would be indexed 15.2. Operand width is going to be 16. Oh no, it's going to be 1. Or 0. Destination indexed 15.2. So why did that fail? So that's not what I want. So it's the source that's wrong. What did I screw up? So that's correct. 15. Destination is 1, 0, and 0, 1. Should be indexed. Should be right here. That could explain it. It thinks to register direct. Four 9 or 4F 9F. Yeah, that should be correct. Source. Why is source 0? Is my shift wrong? Oh, it should be 4. No, it should be 4, 5, 6, 7, 8. I might have done my math wrong. Where's continue? So it's 0, 1, 2, 3, 4, 5, 6, 7. Oh. So this would be 0, 1, 2, 3. This is 4. This is source addressing. That's 6. That's 7. That's 8. 9, 10, 11. That's 12. Register source. What the fuck are we at? So our source addressing is 0. It could be their mask is bad. Source mask. 1, 0, 0, 0, 0. Register mask. Where are... So the destination is correct. Address source. That seems right. AD is 0. It should be 1. For whatever reason, this octet seems not correct. So our code is 4 and our source is 15. So this is all correct. Our destination is why is that? To operand destination. Like that, will that make a difference? That worked. I wonder if we need to have the full bits. It's not the magic fix, is it? So the destination is 15. Oh, it was 15 before though. I wonder if this is one of those issues we had last time, in precedence issues. Yes, it read destination correctly. So the opcode, the destination. $22.39. So this is the one that we just read. I just didn't have the leading 0 there. Whoa. Did I type it wrong? I did type it wrong. code has been right the whole time. I just screwed up. Okay. All right. Oh. And if we take off one of these, it should fail. It'll give us like a, I don't know, some kind of like slice issue. No destination argument present. All right. All right. And I'm going to call it here. I'm going to save this, push it up, and we're going to do this. I'm going to probably do some refactoring off stream just to clean stuff up because it's not the most interesting, like I said, and probably get tests written. And when we come back, things probably will be in a much better place, a little more organized, more comments, more tested, and we can start on getting the display traits implemented so that we can actually print some instructions. You know what? This isn't a branch. Decoding implemented. Need to add tests. Cool. All right, code's up. I'm gonna take off. Have a good night, everyone. Hope you enjoyed it. Probably back again, maybe like on Wednesday or sometime next week. And hopefully this will all be in a much better state and ready to go for instruction printing. Thanks. Have a good night.